All right. Hello again, everyone. I know we didn't turn off the mic, but I just want to make sure that you can hear me. Those that are online, if you can give us a signal. We good? Okay, excellent. All right. So for this next section, we are going to go through a very basic intro to the active chilled beam software. This one's nice because I get to sit down, so I'm going to be over here. Hopefully everyone can kind of see me, but more importantly, that you can see the screen. So first thing I kind of want to show you where to find it, how to locate it. There is a little bit of I think it was a Windows update that requires us to do something to the file once you download it. I know sometimes offices will run into macro blockers, so hopefully your office or firewalls allow the use of macros because this software is based out of Excel and uses macros. You can get it to basically any landing page of a product. You go down to software and you can download for free. We don't need credit card, any of that info. And you could also go up to next to products, there's a tab for software. And then the active beam selection program is also there as well. So you can just download it. I'll go ahead and just show you the full process here. Right. The other thing is what you need to do is go to properties. So right click, go to properties, and then this is probably what you're seeing if you had just downloaded that. I don't know if anybody's keeping up or here in the office or online, but just click unblock if you trust us, I guess, and go ahead and hit apply. And that's going to allow you to run a lot of the macros in software. So that's just a kind of an FAQ free tip for everyone. So you hit apply, okay, and then it should allow you to unlock everything. Okay, so the software, this is basically what it looks like. And in fact, when you first open it, just give it a second to think. When you first open it, it's going to be on an input form. So it's a very simplified version of that performance sheet that I was showing you earlier. Just give that a second. All right, hang on. Sorry, I've upset it. It's temperamental. Let's see. Let me close this. All right, so maybe it doesn't like if you go backwards. Let me open up the selection software. And really the input form, again, it's just simplified and it allows you to copy in just these initial values for the input. So I know there's a lot of info, when you're first looking at this for the initial case where you opened it, but really it's a very useful, helpful tool to expedite the process of designing with Beam. So, starting with the left side here, we've got any green cell are input cells. So that's where you can go in and manually input, data such as the product name. So we can just say training session. Elevation, so that's going to impact, the air performance. So you can actually put the project elevation. We've also got noise criteria, room conditions for the dry bulb, both for cooling and heating. So you can set those to different. These are all default values right now. We'll say NC30 for this example. And then primary air conditions. Again, I mentioned earlier, as opposed to 5554, which is the typical, overhead all air case, our primary air for chilled beams, the default at least for this is 55 at 80%, so 51.6. In fact, it was very similar to the example I was showing in the slides earlier, the earlier session. And then you can dictate a maximum airside pressure drop. So if you wanted to just say, 0.8 again, because that's what Chris was saying earlier. So let's keep it at 0.8. It will flag on the output side any of the, we call it exact pressure. So that's the resulting pressure for the selection on that line. It'll show red or orange if you're a little bit off. Red if it'll get really angry if you're too far off. So that way you can identify and address that concern. Enter water conditions. For this, we've got 57 degrees, which is, in that range of 2 degrees above the dew point for assuming 55 degrees we talked about earlier. And then for heating, so we can do 105 to kind of keep in with Matt's examples earlier of electrified buildings. You can add glycol percentage, maximum water pressure drops, all those sort of things. There's also a building summary tab. I don't think it's going to show anything right now, but I'll show that to you in a little bit once we get some selections. There's also the auto select, which I'll show you. You can do it individual room case or all rooms and all zones at once, which is really handy. And then you've got total quantities for the project at the top. So this is going to give you a nice snapshot of everything you've selected so far. What's the total primary air, CFM, for all of the rows totaled up, the total amount of beams and the linear feet of beams. So that's kind of helpful to keep an eye on that one. So if we go to, I've got this example exercise. Just open the data here. And let's say you've got, you're pulling from your load checksums, which would be your sensible and then your latent, of course, that you're pulling individually. And you put those into Excel or output them into an Excel format. And you can tag them for each of the zones. What we want to do is line it up based on the input into the software to make it as easy as possible. You could do it individually, of course. But we've got room name, square footage, sensible load, latent load, the heating load, and then the primary airflow. And then the number of beams, you could put those in there, but through the auto selection software or just kind of trial and error, you can change the number of beams in the zone based on the ceiling space or the required amount. So I'm going to come over here. This is already laid out just for the sake of time. So I'm going to copy this over into the performance software, and you want to paste values. There we go. We'll paste these values. Primary airflow. The reason that the font is blue is because that's something I inputted. So if we take, I think it's this one, 220, and you delete it, it's going to automatically calculate the amount of primary air. So what's going on here is if you've got like I think it was 220 before. So if you've got a ventilation requirement, but the latent is driving a higher airflow rate, so it's going to be calculating based on the psychrometric values and pulling in this primary air condition. So based on your primary air that you've inputted, it'll calculate that if you just delete that cell or don't input anything. So that's kind of handy just to know and be aware of. Let's see. So as an example, if we were looking at an office example, we won't get through 2 examples. We'll just do this first one here. But typical layout, we've got the top, we'll say just north side of the building. We've got 3 offices. Zone 4 is a conference room, and then Zone 5, which is a small office. Zone 6 is the open office, 2 more private offices, and then a sort of a walkway corridor area. And you'll notice that Zone 6 and 9 have a rather high latent load, so we'll see kind of what to do in those cases when you've got a high amount of latent requirements. We could provide this afterwards too, so this is just the loads that we've put into the Excel file. So let's go over here to select model. So there's no performance yet because we haven't selected a beam model. So let's come over and select, say you really like that two-way discharge look of the ACBL. That's also our most common one, so we'll just assume that for now. And then you can copy that and paste it. Now keep in mind, one of the fun little quirks of this, because of the macros, you cannot control Z, okay? So I know everybody's like, what? That's that, you can see challenges arising. So just keep that in mind that you cannot control Z due to the way the macros are written. So it's written in pen, everything. All right, so I just copied in to select a model, and now we can see that there's values. We've got a lot of cells are already, they're white, so that's basically saying that this is satisfied. If you look at 5500 BTUs for sensible, 800 for latent, you can see we're getting, that's essentially right on point. You saw me, I didn't cheat, I didn't, put these in, sneak them in or adjust them, so it looks like we've got a couple of spaces satisfied. The other thing, let's see, we've got 2-pipe coil selections. For all of these, you can also select 4-pipe. So that'll impact the performance. So roughly 25% of our coil circuitry is dedicated to heating, and 75% is for cooling. So, you're going to see a little bit of a derate on cooling and heating when you go to a 4-pipe. So that's going to be accounted for in this software. Coil circuiting is all naturally automatically selected for you. All right, so I guess let's continue going over. So we've got the target pressure of 0.75. Let's see. And then the inlet size. So again, all those green cells, you can adjust that. So if you're a little high on noise in a certain case, you can go to a larger inlet size, and that can help with noise. GPMs, if there was hot water heat requirements, you can those would populate. To the right, we've got the air side data, so you can see this. Nozzle code wouldn't be too important for you for most of your involvement with the project, but that's just something that we have there, and you could put on your schedule if you wanted to, but that's really just for our sake, and then for balancing. And then here's the dBA, adjusted dB sound levels, and also the NC level adjusted for room attenuation. So if you follow my cursor, I went over to the left, and you can adjust the amount of absorption you have in a space. So if you got a lot of hard surfaces, maybe 10 dBA is not as accurate for your space. You can adjust that. And then the water side data. So here it's only populating chilled water, because that's what we've got requirements for. And if we're going through this and there's any questions, do let me know. I know it's a lot to take in at once. It really takes, getting in and messing around with the software. And of course, we along with Buckley are here to help if you start to look at one of these. Use this for one of your projects. All right, so let's go down and address all these red cells. So we've got one unit in this zone. Let's see, this is, just to give you perspective, this is zone 6. We go back to our layout here, our fictitious project. So it's a large open office, and again, it's got a lot of latent required for the zone. One beam is not going to do it, even though we've got the 9-foot unit over here selected. So let's go over here to auto select an individual zone. you just need to click on any of the cells that are in that row. So do that first, and then go up here to individual room. And then this is probably your biggest friend within this software. So this is going to expedite the process. And again, get you 80 to 90% there in most cases. So you can optimize it for quantity. If you don't want, 2,000 linear feet of beams in a 800 square foot space, that's physically impossible. You can sort of bounce between these two. Let's minimize quantity for the sake of first cost. You can allow it to adjust. Quantity, of course, is fixed here because we're saying adjust or optimize for quantity. If you select primary air, you can either allow it to adjust the quantity or not. So maybe you're at an individual zone and architecturally you want a certain length of beam and that's kind of static. You can leave that and then allow it to adjust the length. You can also do even lengths if it needs to match a ceiling grid. So let's go back to optimize for quantity. That's probably the most commonly used approach. And then let's hit auto select. So if you're doing a really big file, this is where you go get a coffee, or get some food. Maybe you take someone you do a good deed and you bring them a Coke, whatever you choose to do. And then you come back. So we did one zone. That's why it's really quick. And you can see that we've essentially satisfied, all the cells are not red that were red before. And we're a little high on the latent load, which you could see here. So maybe you choose to come over and reduce the airflow rate. Yeah, and then so that caused an effect of the sensible not being met. So we've got 2.4. Okay, so it's yelling at me. So it's going to leave that there. Do you want to replace it? Nope. All right, so for this one, try 8 and then reduce the. So we're getting closer. Let's see. Yeah, so it's just a little bit of a back and forth on that. And you might be a little on the high end with the performance. So kind of what's driving it obviously is the latent requirement. So we've got a high amount of airflow. So usually if you're overshooting the sensible load, we can come over here and adjust the GPM downwards, and it's going to kind of keep you within that range of 0.5 GPM to 2.5 GPM. We come down to here on this bottom selection. Let's say we got another case where there's quite a bit of outside air required for the latent load. Primary air is definitely not enough to account for that. So let's do another auto select. Individual room, just quantity. Found a solution. That's always a happy prompt. And then you can see here that it's still not quite satisfied. So just the number of beams, just kind of trying to bring it down to. Yeah, so this one, if we go down to that minimum airflow, still a bit high on the sensible load. We're closer on the latent. So you can kind of see the iterative process, what we're talking about with the chilled beams, just trying to get the outside air, minimizing that primary air and making sure we're not overshooting on the sensible load. So this one is a little satisfied for zone 9. So we've got eight units. The building summary that I was talking about earlier, so I'm just moving my cursor down to the bottom left. And so this other tab that shows building summary. This is a nice tab to refer to, once you finish most of your zones. You can kind of see this ratio. I find it helpful to see, how much of the energy are we moving in the building with the water and hydronic system compared to the air side. So once you get below, like if this was the inverse, where if you were below 40% of the water side was conditioning the building, you're kind of moving into that that zone where the chilled beam is turning into an expensive diffuser, right? Because then you're using a whole lot of air to move throughout the building to get the performance into the spaces. So it's just something as a balance to make sure that we're optimizing the energy and really that decoupled system and making sure we're moving as much energy through the water. So hopefully that makes sense for everyone here and online. All right. The last thing I want to show, oh, I promised I would show throw data. Okay, so I clicked the throw data button up at the top on the performance sheet. And so this is kind of neat because you can actually select, again, you want to select the zone that you want to zero into. Go up to here and press room dimensions. And this is going to give you a little bit of a view on the throw patterns in the space. So if you have multiple beams amongst each other or next to each other, you can basically select this top left input is the distance from the center line of the beam to the perimeter wall. So if that's within, let's see, zone 1. So if we put that, already laid all of this out, so 2, 4, 6, 8 feet away, just counting ceiling tiles. So 8 feet away, you could see that for a 10-foot tall space, normally these cells are a lot closer to what you're actually adjusting, so it's a little off because I'm using a surface. But this is the total height for the space, which you can adjust. So we'll leave it at the original 10, and then just whether you're a seated, basically the occupant height where the head location is. So we'll say seated 8 feet away from the perimeter wall. It should be 33 feet per minute by the time it reaches 3.5 feet above the finished floor. If you have two in the room, you can select the distance between the two center lines of the beams. And what this feet per minute airspeed value is giving you is if there's any collisions, and making sure that you don't have any collisions and high airspeeds because of that.